Okay, so we're going to make a substitution again. We've been doing this for a while. The substitution we're going to make is x equals u plus v and y equals u minus v. We're going to plug it in, and we're going to try to figure it out. All right? Let's see what happens. So in the first equation, when you plug it in, right, remind you the first equation is x plus y. So we have u plus v, u minus v. Add those together. You're going to get 2u equals minus 2, so that means u equals minus 1, right? Then what you're going to do, you're going to plug in the u plus v into the x in the second equation, and u minus v into the y in the second equation, and multiply out. I want to point out, it may be more productive to just use the minus 1 now. You can do that. What I did was I went through it, and the reason in general, let's say the u wasn't a nice number. Minus 1's a nice number, by the way. It might be easier just to do this over here. But the bottom line, and I know it takes work and effort, you're going to get this over here, all right? If you do the multiplication and combine like terms and things like that, all right? So the next thing is, let me make sure I'm saying that true. Okay, yeah, I did that number over there. You know, now you plug in the minus 1 for the u, and it's relatively simple. All right, what are you going to get? Minus 4 minus 16v squared, and then minus 12v squared. Then I would look at this. I would rewrite the equation, by the way. And what I did was I rearranged it, descending powers of v, and it looks quadratic in form. And then I certainly divide it through by a common factor. I guess that was 4, yeah. Or minus 4, depending on how you look at it. I factored it. I got this over here. And then I get a bunch of conditions for what v could be. So, for example, looking at that, and again, I want to remind you, we know the u is minus 1. Now we have 3 separate conditions on the v. So, for example, over here, this would be v is minus 3. This would be v is plus 3. This over here is complex, all right? Nightmarish, but you can still write it down. All right, let me just explain that to you. This is 3v squared equals minus 31, v squared minus 31 over 3. Multiply top and bottom by 3, you can get minus 93 over 9. So one says, why'd you do that? So I have a rational denominator. What's v going to be? Plus or minus I root 93 over 3. And that's where that's coming from, all right? So, you know, someone says a lot of work to get there. It is. There's no doubt about it. But once you do that, like, for example, once you know that the u is this and the v is this, it's pretty easy to write down x and y. And what's the x going to be? The sum of u and v. And what's the y going to be? Well, you don't remember. It's u minus v, right? So what's u minus v? I get these backwards sometimes. That's going to be plus 2. Now let's do this one over here. And that would be 3 plus minus 1, which is 2. And then what do you get for the y? It would be u minus v. And that'll be minus 1 minus 3, which is minus 4. Relatively simple. We'll look at a picture later. The complex ones, you know, I well, you know, for the most part, avoids this. You know, again, I want to remind you that the u is minus 1. And so what are you going to do over here? Get in terms of thirds, so it's really minus 3/3. Same thing as minus 1. Well, you're going to add it to v. Oops, I didn't mean to do that. I did it again. All right, and v could be either plus or minus, so I said added to it. So minus 3 plus, minus 3 minus, all right? And then what's the other guy going to be? And just, if you can't remember, it's u minus v, right? So what's the u? It's I'm sorry, this is minus 3/3. Put the thirds over there. You're going to do the u minus v. So relatively simple, by the way. I did it again. You get these over here. The point of this, though, I want to really kind of stress this. We're really kind of looking for real points of intersection. So minus 4, 2, that's that one there. The other one, we got 2 minus 4, right? And this is the graph of both of those equations, all right? Thank you.